It is not permitted to splice the neutral wire of a range cable. The National Electrical Code, specifically Article 310.15 (b4), addresses this situation. This section of the code states that the neutral conductor of a branch circuit supplying a range wall oven, countertop cooking unit, or clothes dryer shall not be used for equipment grounding or to ground other equipment. The reasoning behind this prohibition is rooted in electrical safety. The neutral wire is designed to carry current back to the source under normal operating conditions. Using it for equipment grounding presents several potential hazards. Firstly, if the neutral connection becomes loose or disconnected, any appliance connected to it could become energized with the full voltage of the circuit, creating a significant shock hazard. Secondly, using the neutral for grounding can cause objectionable current flow on the grounding path. This can interfere with the operation of sensitive electronic equipment and create electromagnetic interference. Thirdly, if the neutral wire is carrying a high current, the voltage drop along the wire could cause the grounded metal parts of the appliance to be at a different potential than the earth ground, again creating a shock hazard. In the described scenario, where a service panel is being upgraded and moved, resulting in the existing range cable being too short, splicing the neutral wire is not an acceptable solution according to the NEC. The code mandates that the neutral conductor remains isolated from the equipment grounding system for safety reasons. Instead of splicing, the proper course of action is to replace the existing range cable with a new cable of sufficient length to reach the relocated service panel. This ensures that the neutral conductor remains intact and that the equipment grounding system is properly installed. Now, let's delve deeper into the implications of Article 310.15 (b4) and related concepts. It is important to understand the distinction between the neutral conductor and the equipment grounding conductor. The neutral conductor, as mentioned before, carries current back to the source under normal operating conditions. The equipment grounding conductor, on the other hand, provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit in the event of a ground fault. In a properly wired circuit, the neutral conductor and the equipment grounding conductor are kept separate except at the service entrance, where they are bonded together. This bonding ensures that the equipment grounding system is properly grounded and that fault current can flow safely back to the source. When the neutral conductor is used for equipment grounding, as in the case of the spliced range cable, the separation is compromised. This can lead to the hazards mentioned earlier, such as energizer appliance parts and objectionable current flow on the grounding path. It is also important to consider the type of wiring method used for the range circuit. In some older installations, the range circuit may be wired with a 3-wire cable consisting of 2 hot conductors and a bare neutral conductor. In this type of installation, the neutral conductor is sometimes used for equipment grounding, although this is no longer permitted by the NEC. In newer installations, the range circuit must be wired with a 4-wire cable consisting of 2 hot conductors, a neutral conductor, and a separate equipment grounding conductor. This ensures that the neutral conductor and the equipment grounding conductor are kept separate, and that the equipment grounding system is properly installed. Now, let's discuss the practical implications of replacing the range cable. When replacing the cable, it is important to select a cable of the appropriate size and type for the load it will be carrying. The size of the cable is determined by the amperage rating of the range circuit breaker or fuse. The type of cable is determined by the wiring method used for the range circuit. It is also important to ensure that the cable is properly installed and that all connections are made securely. When making connections, it is important to use the proper connectors and to follow the manufacturer's instructions. It is also important to torque the connections to the proper specification to ensure a good electrical connection. In addition to replacing the range cable, it may also be necessary to upgrade the service panel to accommodate the new cable. If the existing service panel is not large enough to handle the additional load, it may need to be replaced with a larger panel. When upgrading the service panel, it is important to ensure that the panel is properly grounded and that all connections are made securely. It is also important to follow all applicable codes and regulations. In summary, splicing the neutral wire of a range cable is not permitted by the NEC. Instead, the proper course of action is to replace the existing range cable with a new cable of sufficient length. When replacing the cable, it is important to select a cable of the appropriate size and type and to ensure that it is properly installed. It may also be necessary to upgrade the service panel to accommodate the new cable. By following these steps, you can ensure that the range circuit is safe and compliant with the NEC. Let's explore some additional considerations related to electrical safety and the National Electrical Code. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. The NEC is adopted by many states and local jurisdictions, and it is important to comply with its requirements to ensure the safety of people and property. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock and other hazards. Firstly, always de-energize the circuit before working on it. This can be done by turning off the circuit breaker or fuse that supplies power to the circuit. Secondly, use properly insulated tools and equipment. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical equipment in wet or damp conditions. Fifthly, if you are not comfortable working on electrical equipment, hire a qualified electrician. In addition to following the NEC and taking safety precautions, it is also important to maintain your electrical system properly. This includes inspecting your wiring and equipment regularly for signs of damage or wear, and replacing any damage to worn components. It also includes keeping your electrical panel clean and free of obstructions. A well-maintained electrical system is a safe and reliable electrical system. Now, let's discuss some common electrical code violations that homeowners should be aware of. One common violation is overloading circuits. This occurs when too many appliances or devices are connected to a single circuit, causing the circuit breaker or fuse to trip. Overloading circuits can be a fire hazard, as the wires can overheat and ignite nearby materials. To avoid overloading circuits, distribute the load evenly among different circuits. Another common violation is using extension cords as permanent wiring. Extension cords are intended for temporary use only, and they are not designed to handle the continuous load of permanent wiring. Using extension cords as permanent wiring can be a fire hazard, as the cords can overheat and become damaged. To avoid this violation, install permanent wiring for all appliances and devices that will be used on a regular basis. Another common violation is improper grounding. Grounding is an essential safety feature that helps to protect people from electrical shock. Improper grounding can create a shock hazard, as electricity can flow through unintended paths to ground. To ensure proper grounding, follow the NEC requirements for grounding and bonding. Another common violation is using the wrong type of wire or cable. Different types of wire and cable are designed for different applications, and using the wrong type can be a safety hazard. To avoid this violation, select the appropriate type of wire or cable for the application. Another common violation is making improper splices. Splices are connections between two or more wires, and they must be made properly to ensure a safe and reliable connection. Improper splices can create a fire hazard, as the wires can overheat and become loose. To avoid this violation, use the proper connectors and follow the manufacturer's instructions when making splices. In conclusion, understanding the NEC and following proper electrical safety practices is essential for protecting yourself and your property from electrical hazards. If you are not comfortable working on electrical equipment, hire a qualified electrician. Remember, the information provided is for general guidance only, and it is not a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work. Let's further elaborate on the specific code article 310.15 B4 and its practical implications for range and dryer installations. The core principle behind this regulation is to maintain a clear separation between the neutral current carrying conductor and the equipment grounding system. This separation is paramount for ensuring electrical safety and minimizing the risk of shock hazards. In older electrical systems, it was common practice to use a 3-wire connection for ranges and dryers, where the neutral conductor was also used to ground the appliance chassis. This configuration relied on the assumption that the neutral conductor would always provide a low impedance path back to the source, effectively grounding the appliance. However, this practice has several inherent risks. Firstly, if the neutral connection becomes loose or corroded, the appliance chassis can become energized with a voltage potential relative to ground, creating a shock hazard. Secondly, even with a solid neutral connection, a voltage drop along the neutral conductor can cause the appliance chassis to float at a potential above ground, increasing the risk of nuisance tripping of ground fault circuit interrupters, or GFCIs, in other circuits. Thirdly, using the neutral for grounding can create objectionable current flow on the grounding system, which can interfere with the operation of sensitive electronic equipment and create electromagnetic interference. To mitigate these risks, the NEC now requires a 4-wire connection for ranges and dryers, where a separate equipment grounding conductor is run from the appliance to the service panel. This dedicated grounding conductor provides a low impedance path for fault current to return to the source, tripping the circuit breaker and energizing the circuit in the event of a ground fault. The 4-wire configuration ensures that the appliance chassis is always at ground potential, regardless of the condition of the neutral conductor. When upgrading an existing range or dryer circuit to a 4-wire configuration, it is important to carefully follow the NEC requirements for grounding and bonding. The equipment grounding conductor must be properly sized and connected to the grounding electrode system at the service panel. The neutral conductor must be isolated from the appliance chassis and connected only to the neutral terminal in the appliance. It is also important to ensure that the appliance is properly labeled to indicate that it is connected to a 4-wire circuit. In addition to ranges and dryers, the NEC also addresses the use of neutral conductors for grounding in other applications. In general, the NEC prohibits the use of neutral conductors for grounding, except in specific circumstances, such as at the service entrance and in certain types of separately derived systems. These exceptions are carefully regulated to ensure that the grounding system is properly designed and installed. Understanding the NEC requirements for grounding and bonding is essential for ensuring the safety of electrical systems. It is important to consult with a qualified electrician or electrical inspector before performing any electrical work to ensure that the work is done in compliance with the NEC. The complexity surrounding neutral and grounding conductors highlight the need for expertise. The separation between the neutral, which carries current, and the ground, which provides a safe path for fault current, is a fundamental safety principle. This principle is the foundation for the NEC regulations on grounding and bonding. When electricity flows in a circuit, it must have a complete path. The neutral conductor provides this return path under normal operating conditions. The grounding conductor, however, is not intended to carry current under normal conditions. Its sole purpose is to provide a low impedance path for fault current to return to the source in the event of an insulation failure or other fault condition. When a fault occurs, the fault current flows through the grounding conductor back to the source, tripping the circuit breaker or fuse and energizing the circuit. This rapid energization minimizes the risk of electrical shock and fire. If the neutral and grounding conductors are inadvertently connected, the fault current can flow through unintended paths, such as metal water pipe or appliance chassis, creating a shock hazard. This is why the NEC requires a clear separation between the neutral and grounding conductors except at the service entrance, where they are bonded together to establish a common ground reference. The bonding at the service entrance ensures that the entire electrical system is at the same ground potential, minimizing the risk of voltage differences between different parts of the system. In addition to the service entrance, the NEC also permits the use of neutral conductors for grounding in certain types of separately derived systems such as generators and transformers. However, these installations must be carefully designed and installed to ensure that the grounding system is properly configured. The NEC provides detailed requirements for grounding and bonding separately derived systems to minimize the risk of electrical hazards. The specific requirements vary depending on the type of system and the application. In all cases, it is important to consult with a qualified electrician or electrical inspector before installing or modifying a separately derived system to ensure that the grounding system is properly installed. The NEC is a complex and comprehensive set of standards, and it is essential to have a thorough understanding of its requirements to ensure the safety of electrical systems.